Hello, how is it going? Gennaro here, CEO of Cortex Solutions, and today we're going to be talking about advanced malware analysis. Again, we're just building on regular malware analysis, okay? So, yeah, got me there. No crazy guesses, but just know that cybersecurity threats, they're always going to be advancing. If you look around the corner, there's going to be something else coming down the pipeline. So to protect this, we have to understand and study malware in great detail. So this is known as advanced malware analysis. It's critical, very critical, if you're wanting to make yourself stand out in the marketplace. So what is malware? I'm not going to touch too much on this. We've already talked about this before, but just know that malware is, well, a program that's meant to do harm. It's making that program do something it's not intended to do. Some types of malware are going to be ransomware, Trojans, fileless malware as well. Now, fileless malware, we haven't talked too much about this, but it operates in memory. It's not going to store a file on the actual device itself because that's just a better way of bypassing antivirus detection. But the purpose of malware analysis, we know that we need to identify the behavior of the actual malicious code itself. We need to understand how it actually affects the system. What is it targeting? Is it actually changing registry keys? We have to develop a fix and mitigation for this too, because we want to make sure that we can extract it and it won't happen again. The goal is to determine if the file itself is actually malicious or not. So static versus dynamic, which path will you choose? Honestly, it really just depends upon you and what you want to do. So static analysis, this is gonna, basically state, hey, without executing the actual malware, let's analyze it. We're going to look at file strings. We're going to look at hash values. We're going to use a disassembler like IDA Pro, a tool you can absolutely go and download. Check it out. Dynamic analysis, this is going to execute the malware. This is going to actually watch it in real time, see what it's doing. What is it doing? What type of modifying of the registry keys is it going to do? Like I just mentioned earlier. So these are different approaches that you can take. I would say disassembling malware would be ideal though. The reason being is that you can understand the underlying code. If it's meant to change its makeup upon execution, well, you want to know that. You want to be able to see that. So IDA Pro is one of the great sources to go for. And there's also open source as well you can also use too. But ideally, just knowing what tools to use, how to actually understand the functionality of the malware, that's what's going to be crucial. And then because we know attackers, they often obfuscate, right? They're going to hide the malicious code or evade some of the security tools like we talked about, not being able to download the actual malware itself, but executing in memory, right? That's going to be able to evade detection. All right, so polymorphism, like I talked about, malware is going to change its code, right, to evade the detection, but this one is more so it's going to change it, constantly, okay? And behavioral aspects, so knowing about what is this file doing, that's not normal. A user wouldn't do this. A file shouldn't be able to do this, shouldn't be able to modify a registry key or something, or take off a password, if you will. But using these code debugging tools will help you get a better understanding and step through exactly what that next step in the malware process is going to be. So memory forensics, and we talked about it before, just know that this is going to be forensics. It's often going to be RAM, right? They're talking about volatile memory, not non-volatile. And some of the tools you can use for memory forensics are going to be, volatility. That's one of the main ones. I've had a lot of success in that. Because again, we want to be able to uncover things that are hidden. And some of the indicators of behavioral, we talked about before, modifying registry keys. You don't really do that, right? Network activity to the command and control, your C2C, and creating and deleting certain files. So you can map certain behaviors to the MITRE ATT&CK framework. I highly recommend checking that out. Getting yourself a sandbox environment too will be ideal, because we do not, and I mentioned before, do not want to run these potential malicious viruses on production or your home networks. We want to be able to reverse engineer. This is all about the advanced portion. We know about it. Now let's add on advanced reverse engineering to uncover some of the backdoors that may be embedded in it. We also want to be able to utilize the anti-analysis mechanisms because, again, right, we want to be able to thwart what they like to do as in attack vectors, or threat actors, I should say, is disable these traditional defenses. So we want to stay a step ahead. Collaborating with our threat intel, we talked about it before, right? Because there's tons of information coming through. But what information really matters, right? So sharing the malware indicators, hashes, behavioral identifiers, some trends, these help us stay on the other opposite end where we're just expecting, we're waiting for something to happen. A real example could be analyzing network traffic, right? So the scenario here is suspicious network activity points to a botnet command. What do? Well, you can use Wireshark, to find the actual malware communicating with the command and control server. Easy day, right? But again, think about it like this. If you want to understand malware, use some of the tools we talked about. If you want to understand how and why malware is doing the things that it's doing, dive into it. Look more into the aspects and the makeup around it. It's been great. Gennaro here, CEO of Cortex Solutions, and today we just talked about advanced malware analysis. Brought to you by ACSMI. Hope you have a great one. Take care.